Hello everyone, I'm Professor Deepika from Vidya Institute of Technology, Department of Electrical and Electronics. In the last video, we have discussed about the calculation of trapezoidal and quadrilateral time curve, that is the derivation with respect to them. In today's video, we will solve some of the problems related to trapezoidal and quadrilateral curve. So in the last video, we have derived these two equations. So now we will see one by one the problems with respect to this. So the first problem will goes like this. The speed time curve of a train consists of uniform acceleration 6 km per hour per second for 25 seconds, free running for 10 minutes, uniform deceleration of 6 km per hour per second to stop the train, and fourth one they have given a stop of 5 minutes, and find the distance between the stations, average and scheduled speed. So this is the thing we have to calculate in this thing. So if we look at this problem, so this is the speed time curve data they have given for a train. Its uniform acceleration they have given, and the acceleration period they have given, free running period they have given, uniform acceleration deceleration they have given, and the stop time also they have given, but we have to calculate the distance between the stations and their average speed and the scheduled speed. So now let's list out the data. Alpha is nothing but 6 km per hour per second. T1 is nothing but 25 seconds. T2 is nothing but 10 minutes, which is nothing but 10 into 60. We have to convert minutes to seconds. So therefore 6 into 10 into 60, which is nothing but 600 seconds. And we know that how do I calculate maximum speed Vm? So we know that T1, that is T1 is nothing but acceleration period, which is nothing but Vm by alpha. So if I rearrange the term, then what is Vm? Vm is nothing but alpha into T1. I know alpha and I know T1. If I substitute over here, then I'll get 150 km per hour. So this is the maximum speed. Thus we have calculated. So what is T3? T3 is nothing but Vm by beta. I know Vm and I know beta. Therefore, T3 is nothing but 25 seconds. 150 by 6 is nothing but 25 seconds. Next, we have to calculate the distance traveled during the acceleration period, because you know here in the problem they have asked to calculate distance between the station and average speed and scheduled speed we have to calculate. So therefore that is the distance. Actually, the easy way to calculate the distance between the two stations is that in the derivation we have seen that it is the sum of distance traveled during acceleration plus distance traveled during free running plus distance traveled during deceleration. So if I sum all these three terms, then I'll get the distance between the two stations. So what is distance traveled during acceleration period, which is nothing but half into T1 divided by 3600 into Vm. So substitute, we know T1, which is nothing but 25. What is Vm, which is nothing but 150. So therefore I'll get 25 by 48. So what is distance traveled during free running, which is nothing but T2 by 3600 into Vm. So 150 into 600 by 3600, which is nothing but 25 kilometer. So what is distance traveled during braking period? Again, it is nothing but half into T3 divided by 3600 into Vm. So therefore, we will get 25 by 48. So what is total distance between the station? It is nothing but sum of these three distances, which is nothing but D1 plus D2 plus D3. So which is nothing but 26.042 kilometer. Next, what is average speed? We know that average speed VA is nothing but 3600 D by T. So substitute all the data. D is nothing but 26.042 kilometer and T is nothing but sum of all these three periods, that is T1 plus T2 plus T3, which is nothing but 144.23 kilometer per hour. So what is scheduled speed? Scheduled speed is nothing but what? It is the ratio of time traveled during, or here we need to calculate the scheduled speed. Speed is nothing but what? Again, distance by time taken. So distance I can use this formula to calculate the average for the scheduled speed, which is nothing but 3600 D that is the distance, and the time has to be converted into hours, so therefore divided by 3600. And what is schedule speed? Schedule speed is actually the sum of time during run plus stop time, because during the run of a train there will be a stop time also. If I add the stop time to the time of run, then we will get the schedule speed. So therefore this is the formula to calculate the schedule speed. And the stop time is also given, but it is given in terms of minute. So if I want to convert into hour, then we have to multiply with the 60. So 5 into 60, which is nothing but 98.68 kilometer per hour. Sorry, if 5 minutes is given to convert into hour, it is nothing but 5 into 60. So therefore schedule speed is nothing but 98.68 kilometer per hour. So second problem will goes like this. An electric train has an average speed of 42 kilometer per hour on a level track. You see here, average speed is given over here. And between the stops is 1400 meter apart. That is the distance is given. It is accelerated at 1.7 kilometer per hour per second, and is braked at 3.3 kilometer per hour per second. And we also and here we have to draw the speed time curve for the run. So you have so how do I get to know, how do I get to know, is it quadrilateral curve or trapezoidal curve? Means if the coasting period or the coasting retardation, if anything is given in the problem, then that is quadrilateral curve. If anything is not specified, like coasting period or coasting time or coasting velocity or coasting retardation, then that is only a trapezoidal curve. So please keep this in mind. If the coasting retardation or coasting period, if anything is asked in the problem, then that is nothing but the quadrilateral curve. If that is not asked, then that is only the trapezoidal curve. Okay, so to draw the speed time curve here, we need to calculate T1, T2, T3, and Vm also we need to calculate. So therefore, to draw that, we need all those things. So here, first we'll list out the data. We know alpha, which is nothing but 1.7 kilometer per hour per second. Beta is nothing but 3.3 kilometer per hour per second. Distance they have given in meter, that is 1400 meter. We have to convert into kilometer. So therefore, divided by 1000 is nothing but 1.4 kilometer. Next, what is VA? That is the average speed they have given, which is nothing but 42 kilometer per hour. So now, how do I calculate the time of run? That is the capital letter T. So you can see here, so this is the formula to calculate the time T, that is the total time of run. That is nothing but T is equals to 3600 D divided by VA. So substitute, the time for run is nothing but 120 seconds. First of all, we need to calculate 1 by k value to calculate Vm, correct? So in the derivation, we have used the k. K is nothing but 1 by alpha plus 1 by beta. Alpha value is known, beta value is known. Substitute, you'll get 500 divided by 561. What is maximum speed? Which is nothing but Vm. Vm is nothing but what? It is nothing but T by k minus T by k whole square minus 7200 D by k. Substitute all the values. So therefore, we will get the value, which is nothing but 52.0677 kilometer per hour. So this is the maximum speed. Next, what is acceleration period? T1. T1 is nothing but what? It is nothing but Vm by alpha. So we know Vm, and we know alpha. So therefore, T1 is nothing but 30.6280 seconds. What is braking period? T3 is nothing but Vm by beta, which is nothing but 15.7780 seconds. What is free running period? Which is nothing but T2 is equals to T minus of T1 plus T3. So we know T1 and T3, substitute, we will get 73.594 seconds. And now we have to draw the speed time curve. So you can see here, so this is the speed time curve. So this is the curve between speed in kilometer per hour and the time in second. So as I told you, this is the trapezoidal curve, and we know T1, T2 and T3, that should be written over here. And what is Vm? Which is nothing but 52 kilometer per hour. Like this we have to draw. Now we will solve the problem. On quadrilateral curve. So a train is required to run between the two stations 1.6 kilometer apart at an average speed of 40 kilometer per hour. The run is to be made to a simplified quadrilateral speed time curve, so they have only specified. If the maximum speed is to be limited to 64 kilometer per hour, that is the V1, and acceleration is nothing but 2.0 kilometer per hour per second, and coasting and braking retardations are 0.16 kilometer per hour per second and 3.2 kilometer per hour per second respectively. Determine the duration of acceleration, coasting and the braking period. So therefore T1, T2, T3 are to be calculated here. First list out the data. D is nothing but 1.6 kilometer. VA is nothing but 40 kilometer per hour. VM is nothing but 64 kilometer per hour kilometer per hour. And stop time they have given, which is nothing but 30 seconds, and alpha is nothing but 2 kilometer per hour per second. Beta is nothing but 3.2 kilometer per hour per second, and beta C is nothing but 0.16 kilometer per hour per second. So this is the data which is given in the problem. Next, how do I calculate duration of acceleration, which is nothing but v1 by alpha. So v1 is nothing but what? It is the maximum speed, which is nothing but vm. So therefore 64 by 2 is equals to 32 seconds. What is actual time of run? T is nothing but 3600 d by VA, because average speed is known. So therefore it is nothing but 144 seconds. Again, the let speed before applying brakes be what? It is nothing but V2. So therefore duration of coasting is nothing but what? T2 is equals to V1 minus V2 by beta C. I don't know V2. Let us retain as it is and substitute the remaining term, that is 64 and 0.16 seconds. And what is duration of braking, which is nothing but V2 by beta. So I don't know V2, but I know beta. Let's substitute and let us retain this as it is. Then what is actual time of run? It is nothing but T is equals to T1 plus T2 plus T3. So here you know T, you know T1, and T2, T3 are in terms of V2. Substitute over here and you can see here only one unknown is there, that is V2. So therefore you can see here I'll take V2 common, which is nothing but 1 by 0.6 minus 1 by 3.2, and that is equals to 32 plus 400 minus 144. So therefore V2 is nothing but 48.5 kilometer per hour. What is duration of coasting then? It is nothing but T2, V1 minus V2 by beta C, or 64 minus V2 by 0.16. Substitute, you'll get duration of coasting as 96.85 seconds. What is duration of braking? Which is nothing but V2 by beta. So therefore 48.5 by 3.2, which is nothing but 15.15 seconds. So this is how we will calculate the distance, acceleration, or anything with respect to this. So all problems will be similar to that. Okay. Thanks for watching the video. Thank you.